Hi everyone, so in this part I'm going to explain the code.bht from the logic gates activity. So let's get started. So as you can see we are using the same tree library IEEE. We are using the std logic 1164, we are using the std logic ARITH, and we are using the std logic unsigned. Here we have the entity, which name is logic gates. It has uh, x and y as inputs, and we have AND, NAND, OR, NOR, XOR, XNOR, and NOT as outputs. All of these ones are STD logics, as you can see. And here it ends the logic gates entity. Now we have the architecture behavior of the logic gates. So this is how it's going to behave, the entity we are doing here. As you can see here, it ends right here. Now let's go with the logicgates.bht. This is auto-generated from the BHT. This is the only part we modified, and it's the time it waits for each input. We have 10 nanoseconds for each case. We have 0, 0, 0, 1, 1, 0, and 1, 1. So that's everything for here.
Hi everyone, so in today's video I'm going to show you logic gates with the Intel FPGA University program. So the first switch is for the X and the second switch is for the Y. These two are the inputs. Now if you look closely, these here are the LEDs. From 0 to 6 they are the logic gates AND, NAND, OR, NOR, XOR, XNOR, and finally the NOT. Now, what happens if one of the inputs is 1? For example, let's put the X input 1. As you can see, from the logic gate AND and the truth table, if X is 1 and Y is 0, the result or the output is 0 because this is an AND. Now, if the Y is a 1 and the X is a 0, the output is a 0 as well. So, the only way that the output is on or 1 is that you have both inputs in 1 as this is the only way the output is 1. X and Y needs to be on. Now let's go with the second logic gate. This is the NAND, so it's the inverted of the AND. So if both of the inputs are 0, the output is 1. If I put one of the inputs in 1, 1, 0, 1, the output is 1 as well because it's the inverted of the other case. As well, if the Y is in 1 and the X is in 0. If both inputs are in 1, the output is 0. Now let's go with the third case. This one is the OR. Now, if one of the inputs is the X is in 1 and the Y is in 0, the output is 1. 1 plus 1, 1. Okay? So let's go with the other case. Let's put the Y on 1 and the X on 0. 0 plus 1 is 1. Now let's go with 1 and 1. So X and Y are both in 1. And the output is 1 as well, because 1 plus 1, in the case of the OR, it's a 1. Now, if both of inputs are off, or 0, the output is 0, as you can see here. Now let's go with the next um, logic gate. That's the NOR. This is the inverted of the OR. So if both inputs are off or 0, the output is 0. If one of the inputs is in 1, the output is 0. If both inputs are 1, the output is 0. So the only way the output is 1 is that both of the inputs are 0, as you can see here. Now let's go with the XOR, exclusive OR. Okay, for the exclusive OR, if both inputs are 0, the output is 0, as you can see. If the X, for example, is in 1, oh my bad. As you can see, the output is 1. If the other input, this is the case of the Y, is in 1, the output is 1. If both inputs are in 1, as you can see here, the output is 0. Now, let's go with the XNOR, exclusive not OR, okay? So if both inputs are 0 or off, the output is 1, as you can see here. Now, if one of the inputs is on, the output is 0, as you can see there. Okay, so let's put the Y on 1, so you can see that no matter what input is on, the output is going to be 0. Now, if both inputs are 1, the output is going to be 1 as well, as you can see there. Now let's go with the last one, and this is the NOT. The NOT is quite simple. Now, in my case, the NOT is going to work only for the Y, not for the X. So if the Y is on, the inverted of 1 is 0, so it's going to be off. That's the case for the LED number 6. As you can see there, the Y is off, but the LED of the number 6 is on. So if I put this on, the LED number 6 is off because it's inverted. So that's all for today, guys. Thank you so much for watching this video.